A lot of random variables will have the so-called normal distribution. Let's see what it actually means, and we're gonna start with an example. So imagine that you were asked to measure every man in a small city that has 10,000 men. So they gather somewhere in the center of the city, you draw a line where you have different heights in centimeters, and you start measuring one by one the men. If specific man has a certain height, you put this square in the proper place. If more than two people have the same height, you put them one on top of the other one, like we've got here around 180 centimeters. After some time, you will get everybody measured and you will discover that you will have the following graph. And this is the normal distribution. Normal distribution shows you how specific characteristics, in this case height, is distributed in the population that you are examining. So from that we would know that majority of the people seem to have 180 centimeters height and hardly anybody is below 155. When it comes to the maximum, there is hardly anybody above 200 and probably 5. On the x-axis, we've got the value of the random variable. In this case, this is the height. And here we can have on y-axis either the number of people or percentage of the people in the whole population that have a specific value. The normal distribution will be obviously drawn as a line like that. And it's also called a bell-shaped curve because it resembles with its shape the bell. Now let's go briefly through the main characteristics of the normal distribution. So first of all, there's just one peak, and this is located here. There are distributions which have more than one peak. In the case of normal distribution, there is just one dominating value. As you have probably noticed, the results tend to cluster around this peak, the central value. And the central value, which is in the peak, is the mean, in other words, the average result. For the means, we use the Greek symbol of nu, which you can see here. And as we said, it's always in the peak. In other words, in normal distribution, the most likely result is the average result, which makes a lot of sense. And as we said, it is important that the results tend to gravitate, cluster around the mean, the peak. Now, another important thing when it comes to the normal distribution is that the mean divides the normal distribution into two halves, and 50% of results will be below the mean and 50% will be above the mean. So this is right in the middle of the results. Now let's have a look how a normal distribution is described. So to show that something has a normal distribution, we will use the symbol n, and we'll have this bracket where we show the mean is the first thing, and something which is called a standard deviation that we will discuss in the next lecture. But basically, standard deviation is a metric that shows how far away from the mean other results are. The bigger standard deviation, the more further away from the mean other results are. In the case of the height, we have discussed in the first example, for Europe and men, we would have an average mean results of 178.4 centimeters, and then the standard deviation would be 7.6. So this is pretty low, and it shows you how close to the mean majority of the people are. Now, a very important thing is to see what happens when the mean is going up or down. So let's imagine that we start with the mean of 180 centimeters, and then for some reason we manage to make people bigger. So the mean is going up to 190. This means that the whole distribution will also move because the peak has to be around the mean. If nothing happened to the standard deviation, then the shape of the distribution will not change. Now, if the mean is going down, we have an opposite effect. So we move the whole curve, the whole normal distribution to the left. Now, what will happen if we increase or decrease the standard deviation? So we have more or less scattered data. If the standard deviation is going up, you will see that the curve is more flattened. So more results are further away from the average. The opposite effect will have if the standard deviation is going down. This would mean that the shape will be thinner, so it will be more concentrated around the average. Now, the last thing that is worth mentioning that normal distribution is extremely prevalent in the nature, and even things that don't follow normal distribution tend to converge to the normal distribution. Among the things that should be following normal distribution, we can have weight, height, exam scores, size of fruits and vegetables, number of defects on production line. Apart from that, we have variables that are influenced by many factors. Here we've got the so-called averaging effect. And finally, other distribution, as we said, tend to converge to normal distribution.